Yes, I welcome you all for another a beautiful presentation on signals and systems subject. Since long, we are continuously studying and discussing various, types of signals, right? In our previous presentation, that is lecture number 10 of signals and system, if you recall, there we have explained about the impulse signal. What is a impulse signal, or otherwise what is a unit impulse signal and how it is defined, and we have seen its properties, and also we have seen some of examples in examination point of view, right? This is one of the very important signal, mostly can be used in signals and systems, and you will be expected some questions also in your competitive examinations like gate examination as well as engineering service examination. Okay, so in today's presentation, that is lecture number 11, in which I am going to cover some more standard signals or elementary signals. This is what we have discussed in our previous presentation. Means elementary signals or certain standard signals. So out of them, we have seen the unit impulse as the first one, and in today's presentation, I am going to explain you the remaining standard test signals. Out of which, okay, so already impulse we have covered. So impulse signal, basically what we have are under your standard. Let me explain you. Impulse signal, and then step signal, and then ramp signal, and then okay, and then ramp signal, and then you have parabolic signal also. You have parabolic signal also. This is parabolic signal, and then afterwards you have exponential signal. Exponential exponential signal. Okay, exponential signal, and then you have then a triangular. You will have the triangular pulse signal. Triangular pulse signal, and then you will have sync or sync signal, and then signum signal. These are the basic signals you will have under these types of elementary test signals, right? So these are the basic various signals can be classified under a standard test signals or time signals, are also called as elementary signals. So impulse signal, step signal, ramp signal, parabolic, exponential, triangular pulse, sync signal, and then signum signal. Out of which we already discussed in our previous presentation, the first one is impulse signal. Let us see the remaining one, step signal. What is a step signal? What is a step signal, and what is the ramp signal? These we will see one by one quickly, right? So step signal, let us see what is a step signal. What is a step signal? What is a step signal? Step signal is nothing but Actually, it is defined as, the step signal is defined as x of t is equal to, the magnitude is a, for t is greater than or equal to 0, and it is 0 for t is less than 0. This is the definition of a step signal. Clear? So the step signal, it is defined as x of t is equal to a for t is greater than 0 and it is 0 for t is less than 0. This is the definition of a step signal. Whereas unit step, what is unit step? Unit step signal. Unit step signal is nothing but, unit means 1. Unit means 1. Therefore, your magnitude A will be 1 here. So, in unit step signal, the entire definition will be same, that is x of t is equal to, here your A becomes 1. That's why it is called unit step. So, x of t value becomes 1 for t is same limitations of time. It is t is greater than 0 and it is 0 for t is less than 0. That's it. This is unit step signal. Unit step is nothing but your A value becomes 1. Then it is called unit step, or otherwise it is called step signal. If you want to represent in time domain, or so this will be like this. Let us say this is the time versus your x of t, and for t is greater than 0, this is 0 actually. For t is greater than 0 is nothing but from 0 to up to greater than, this is what the period, t is greater than 0 is nothing but this is the period, time period, means 0, it starts from 0 up to goes up to infinite. Clear? For t is less than 0 is nothing but, that is the time period below the 0 level, means this period is your t is less than 0, means it is less than 0. Therefore, for this period your x of t value is 0. Therefore, you don't have any x of t here. All values becomes 0 for this t is less than 0. Only you will have x of t value as a, x of t value as a for t is greater than 0, means from this, means a value is something here. A value is something here. It means that t is greater than 0 is means that from 0 you will have a, let us say 1, let us say 2 and 3 and 4 and 5, and you take, go on. For all these time values, these are the time actually. For 1 you will have a, for 2 you will have a, for 3 you will have a, for 4 you will have a. If you combine all these points, you have a constant line actually, continuous line. That's why it is a straight line actually, like this. It is a straight line. That is what it is. It goes on. It goes on continuously. It goes on like this. This is what unit step. Whereas unit step signal, only instead of a you will have 1 only, because your a value becomes 1. Your a value becomes 1. If you replace a by 1, then this graph now becomes, for this unit step signal, x of t equal to 1 for t is greater than 0, means the same. This is t is greater than 0 period. This is the region for t is greater than 0, and for t is less than 0 nothing but this is the less than 0. This is the definition of a step signal and then unit step signal. Now the second, let us see the definition of the next signal. So here what we are going to see is that the definitions of various standard signals. That's what we are going to see. Here the next is the ramp signal. Next is the ramp signal. Right? What is the ramp signal? Ramp signal is nothing but, it is defined as x of t is equal to some a into t. That's it. For t is greater than or equal to 0 and it is 0 for t is less than 0. Clear? This is the definition actually. X of t is the signal. It is a continuous time signal. X of t value is a into t. Remember that a is the magnitude. A is the magnitude. Your t stands for time itself. Time only. Time only. Is it not? Therefore, so x of t is equal to a into t for t is greater than 0 and it is 0 for t is less than 0. This is what ramp signal. Okay. Then unit ramp means you can define unit ramp also. Unit ramp. This is the ramp actually. What is unit ramp? So unit ramp signal is nothing but in unit ramp signal, wherever a is there, let us use substitute a value as 1, because unit means one, unity. That is the meaning of it. Unit, nothing but unity means 1. Therefore, for unit ramp, x of t is equal to, you substitute a value as 1. Therefore, you will have only t. It is for t is greater than or equal to 0, and obviously it is 0 for t is less than 0. This is the definition for unit ramp signal. And it looks like actually it is a ramp. I think you already know it. Basically, if you draw the graph, this is the time, x-axis is the time, y-axis is your signal x of t. It is a ramp signal, means it is for t is greater than 0, means this is 0 point actually. For t is greater than 0 is nothing but 0 to plus infinite. As t starts from 0, this means that t starts from 0, goes up to infinite. That is the meaning of t greater than or equal to 0. It starts from 0, it goes up to plus infinite. Therefore, from 0, so at 0, substitute the value t as 0. And here let us say 1, 2, 3, 4, 5, 6 and 7 and so on and so forth like that. For t equal to 0, what is the value of x of t? Its value is 0. Means that you will get here x of t value is 0. For t equal to 0, what is x of t value? 0. Okay. For t is equal to 1. So if t is equal to 1, this value becomes, x of t value becomes 1. Therefore, for 1, you will have 1. It is also 2. It is also 3. Like that. Value will be like this. Means that what? So for t is equal to 1, x of t is 1. For t is equal to 2, x of t value is 2. Like that. So 1 to 1 means this is the point you will get from 2 to 2. You will get here 3, somewhere like this, 4. So this 4 and this is the 4, 5 and so on and so forth. So if you combine all these points, then you will get this kind of graph. Actually, it is a straight line like this. This is the ramp signal basically. Your signal looks like this. This is the ramp signal. Is it not? This is the ramp signal. Or okay, or unit ramp, otherwise unit ramp. Is it not? So this is what the definition of a ramp signal, a into t, or simply x of t is equal to t. That much you need to remember. This is what regarding your ramp signal. Then next is the parabolic signal. Next is the parabolic signal. Parabolic signal. What is parabolic signal? So parabolic signal is defined as same, x of t is equal to a into t square by 2 for t is greater than or equal to 0 and it is 0 for t is less than 0. We have to remember this is the definition. Okay, for parabolic, okay, for parabolic, a into t square by 2. Okay, for t is greater than 0 and it is 0 for t is less than 0. This is parabolic. What is unit parabolic? What is unit parabolic? Unit parabolic is nothing but, unit parabolic signal is nothing but wherever a is there, you simply substitute a value as 1. Means it is, if you substitute a as 1, then it is t square by 2 and the limitations are the same. For t is greater than or equal to 0 and it is 0 for t is less than 0. This is the definition. So we must remember the definitions. Very, very important one. Because these are the basic information that are normally required to know and to remember also. Clear? So this is the definition. And if you plot the graph actually, how the graph will look like for this parabolic. So for this expression, if you draw the graph, it looks like this basically. So it is t and it is x of t. And what is definition actually? X of t is equal to take t square by 2. So here substitute x of 0. 0 is nothing but it is 1, it is 2, it is 3, it is 4, 5, 6, 7, 8 and so on and so forth, because and it is for t is greater than or equal to 0 and it is 0 for t is less than 0, means for t is less than 0 is nothing but this is the 0 basically. For t is less than 0 means this particular period less than 0. So in this particular area your x of t value will be 0, therefore you don't have any x of t, means obviously it will be 0, and your graph will be, you will have for t equal to greater than 0 period only, and means that this is what t is greater than 0 period. This is the region t greater than 0, nothing but this is the region. In this region you will get substitute the value. So for t, for what value of t? It is starting 0. So if you substitute 0, 0 by 2 is 0, therefore it is 0. For 1, say for example for t is equal to 1, substitute 1 here, 1 by 2 0.5 means 1, if you substitute you will get 0.5, x of t value is 0.5. And similarly if t is equal to 2, so if t equal to 2 it is 2 square, 2 square means 4, 4 by 2, so it is 2, therefore at 2 you will get 2 actually, at 2 you will get 2. And similarly if you substitute 3 here, it is 3 square by 2, 3 square means 9, 9 by 2 is 4.5, therefore you will get something 4.5 here, 3, you will get something 4.5 like this, clear. And if you substitute, if you go on substituting the values, it falls like this, your graph will be something, it looks like this actually, exponential. Parabolic means something, it goes like this actually, you will get in this form, actually it goes in this way. If you substitute for different values, the graph looks like this. This is what the parabolic, this is what the parabolic, is it not? This is the parabolic signal. And then if you see, next is the exponential signal. Exponential signal, what is the exponential signal? Again in the exponential signal you will have two cases basically. So next is the exponential, okay, exponential signal, exponential signal. So here again you will have two cases. One is the real exponential, okay, real exponential signal, and the second is the complex exponential signal, complex exponential signal. What is the real exponential? Real exponential is defined as x of t is equal to some a into e power some b into t form. This is what your signal means. You don't have any complex quantity in this, okay. So x of t is equal to a into e power bt, where a and b are real values. Your a and b are, these are real values basically. And similarly if you see the complex exponential, under this you will have your x of t is equal to some a into e power j times omega t. This is what the form of complex exponential, a into e power j times omega t, where omega is equal to, we know that it is angular frequency, it is 2 pi f, and finally you can call it as 2 pi by omega, because f is equal to 2 pi by t, it is 2 pi by t, 2 pi by t, okay. And normally one thing you need to remember is that according to your Euler's formula, e power I theta, you know, e power I theta, it is cos theta plus I sin theta. This is Euler's formula, no? This will be used in complex exponential, but in real exponential you will not get any this kind of things. So normally your real exponential are, normally they are not a periodic basically, but whereas your complex exponential comes under periodic basically, right, that is what the simple thing. Whereas again here a and b are real values basically, and again here there is a possibility your b can be positive or can be negative. Your b can be positive or can be negative. If it is b positive, if for b positive, your graph will be something like this. Your graph will be, if b is positive, some a will be like somewhere, and your graph will be somewhere. It will starts like this. If you plot the graph, it is exponentially increasing function. For b is positive, if b is positive, then the graph will be, this is t actually, this is t, this is your x of t, y axis x of t. It is exponentially increasing function like this. It will be exponentially increasing for b is positive. Whereas for b is negative, so in competitive examinations, no, so for in multiple choice you may get these questions. In complex exponential, if b is positive, what could be the graph, what could be the wave graph? This kind of graphs they will ask, they will give you, and you need to select which one is the correct one. And similarly, if b is negative, this is for positive, and similarly if b is negative, this is t actually, this is t, this is 0, this is x of t. Clear? If b is negative, then obviously this will be something like this. Your graph will exponentially decreasing. This is exponentially decreasing. For b is negative. This is for b is negative. This is for b is negative, and this graph is for b is positive. This is for b is positive. It is exponentially increasing function. B is positive, whereas for b is negative, it is exponentially decreasing function. That you need to remember. This is in general real exponential, whereas this is the complex exponential. In complex exponential, the waveform will be represented on a complex plane. On a complex plane. What is a complex plane? Complex plane is also called as some S plane. Nothing but it has a real part as well as the imaginary part. It looks like this. It has the complex plane will has, this is the real part actually. This is real part, and this is the your imaginary part. Imaginary part actually. And here if you, the magnitude is a basically, so then if you, that is nothing but the length of the vector, you can say. This is what the length of the magnitude, and with this length if you able to draw one circle, then normally you will have this kind of things. One dotted one circle actually, it looks like one circle basically. And here this is what the angle omega into t, this is the angle basically. Okay, so like this is your complex plane, so it rotates actually. This a magnitude will rotate. In complex exponential signal, the say the x of t will be represented in this way. That have, because I already explained, as per Euler's formula, e power I t, it is cos theta plus I sin theta. This is the real part basically. This cos theta is nothing but your real part. This is what real part. Whereas I sin theta comes under imaginary part, because I is there, no, and therefore sin theta is the imaginary part. This is the real part. Therefore, it is a combination of real part as well as the imaginary part. This is the representation of your, complex plane of the exponential, complex exponential form basically. And then if you see that, next is the triangular pulse signal. Next is the triangular pulse signal. How this signal will be defined? How a triangular pulse signal can be defined? So the definition is very easy actually. X of t is equal to, means the triangular pulse signal is defined as x of t is equal to, it is a triangular, therefore delta of t, it can also be represented base a, suffix a you can call. Delta suffix a of t, delta t, nothing but triangular, it is triangular in nature. Okay, this is equal to actually 1 minus magnitude of t by a. That is the definition of this. This is for magnitude of t is less than or equal to a, and is equal to, it is 0 for magnitude of t is greater than a. Means for this limits magnitude of t less than or equal to a, for this limitation your x of t will be defined as like this, 1 minus magnitude of t by a. That is the definition actually of this triangular pulse signal. And if t is greater than a, if the t value is greater than a, your x of t becomes 0. And how this can be represented? Very simple actually, very simple. This is the time basically, this is the time axis t, and then this is your x of t. If you represent on this something like this is your magnitude 1 basically, if you see, and it is 0, this is 0, this is plus a, this is minus a. This is the width actually, if you see, this is the triangular pulse signal. It is plus a and minus a. This is what actually here will represent in the definition. This is the signal representation. The triangular signal can be represented in graphical form like this, right? This is what your triangular pulse signal. And then the next one is the signum signal. Second is the next is the signum signal. What is the signum function? This is another important function actually. Okay, signum signal. What is a signum signal? How it can be defined? Signum is defined as x of t in general, and signum is represented as sgt. Is it not? sgt or sgn of t, sgn of t. This is signum is equal to, it is plus 1 for t is greater than 0, clear, and it is minus 1 for t is less than 0. That's it. That is the definition of signum. It is plus 1 for t is greater than 0 and its value is minus 1 for it is less. How it could be represented? Very simple. It is very simple. This is time versus x of t. This is 0 basically. For t is less than greater than 0 means this is the area, region, otherwise t is greater than 0. And this is the period for t is less than 0. And for t is greater than 0, what is the signum of t? It is x of t, or otherwise also called as sgn of t. Both are same actually here. And it is plus 1. This is plus 1. Means for t is greater than 0, plus 1 means your graph will be like this. It is goes like this. Whereas minus 1, here the value will be minus 1. This will be in this form. Like this. Okay. It looks like this. Like this. Understood? Clear? So means for t is greater than 0, your graph will be like this, and for t is less than 0, it will be like this. It will be like this, and it is, however, it will be there like this. Clear? This is the definition of a signum signal. And finally, we will see the sync signal, the last one. The last in this today's presentation is the sync signal. What is a sync signal? This is another very, very important standard signal, that is sync, S-I-N-C, sync signal. The sync signal, what is sync signal? It is defined as x of t is equal to, normally it is, okay, sync of t, S-I-N-C of t, basically this will be x of t, nothing but your sync signal, can be represented or can be defined as SINC of t, nothing but sine t by t. That's it. Sine t by t. This is for minus infinite less than t is less than infinite. That's it. So your t value, your time value must be within this. Means it is a continuous one actually. So how it looks like, it is something like this. It is something like this basically, and say your magnitude is something, it is x of t versus this is t basically. You can take it your magnitude as 1, let us say, and it will be something like this. I will show you this something. It is decreasing, it is continuous, it will goes like this, and similarly like this. Slowly your amplitude will be decreases actually. Yet here you will have maximum value, and slowly it will decreases basically. It will go on decreases actually. This type of signal is called as a sync signal. Sync signal. Clear? So these are the basic standard signals or elementary signals. These are called in signal system subject terminology. Right? I think these are the basic definitions. Nothing to worry about these signals definitions. You just remember. Okay. And sometimes in examination you can be asked the definitions. Clear? And I think we will finish off this presentation here, and we will continue in our subsequent presentations. Then we will move on to see the next topic, that is what is a system and what are the classifications of the system, right? That is another very interesting topic actually, that we will see in our subsequent presentations, right? So we will finish off here, and we'll see in the next presentation. Okay, thank you for watching.